All right. So we were talking about very simplistic approaches to science, just to as an example to understand it better. But the reality with science is you're often asking a question or proposing an answer to a problem that where you can't control all the variables. So especially ecology type studies, there's so many variables that you can't, the only way you can deal with it is to look at it through statistics and through probabilities. So the probability is a measure of how likely something is to occur. And it doesn't tell you what will happen, but it will tell you what likely is going to happen. And it ends up with science. We have sort of a benchmark that that we use when we're evaluating an experiment. And the probability value that you go for is a probability that it's only 5% likely to have been by chance. So you do this big messy experiment, and the possibility is that maybe it was just your data just accidentally looks like it supports the hypothesis. But if you're 95% certain in terms of the statistics and the math, you say, okay, we're going to accept our hypothesis. So the probability that is significant in science is 5% chance that it was just a statistical or an error, and there's a 5% chance that you screwed up and your hypothesis wasn't really supported by this messy data. Here's the thing, is a lot of times when you're studying stuff in nature, it's not like a drug test where you're trying to develop a new drug. You have all kinds of conditions out there in the world, and you're trying to compare this location with that location, and yet they're experiencing different kinds of conditions. So we have natural experiments, which are out in nature, and you're trying to tell something. A really famous natural experiment had to do with the Hudson Bay. Yeah, the Hudson Bay Company. And if you know anything about history, and if you think about it, the Hudson Bay Company was a fur company, and they bought skins from animals that were captured in traps in like the 1700s. I mean, a long, long time ago. Now, the company was in existence for like 300 years. And so this would be an example of a natural experiment where they were looking at the populations of lynx, that's a cat that kills defenseless little rabbits, hares. So snowshoe hares are their primary prey of the lynx. Now, the lynx, so what they did is they said, well, let's look at how many pelts, how many skins from the hares were being caught relative to how many skins of the lynx were being caught. And so what they found is whenever the numbers of rabbit, hares that were trapped, a year later, or a year or two, maybe a year later, the number of lynxes started going up. And then when the numbers of hares were going down, a year later, the lynx population, the numbers of pelts, skins, went down. And so what people have realized that this is a natural experiment where they're looking at population dynamics of lynxes and hares. And what did it tell them? It told them that that the lynx were benefiting. They were eating the rabbits, and so when the rabbit population numbers went up, then the lynx were doing pretty good. We said, we got Hassenpfeffer tonight for dinner. That's a rabbit dish. We got rabbit tonight for dinner, and so they started having more babies. And then when they had more babies, what do? They eat more rabbits. Rabbit numbers go down. Times become tough, and you have fewer and fewer lynx. So this is an example of a natural experiment where you can't control. I mean, there's so many factors, but you can still read into it something. Now, we can have that other kind of experiment that I was talking about where you literally are manipulating everything involved, and you can really control everything. So with any kind of drug test, what you do is you have patients that have whatever the problem is, and you have some of them are going to get the drug, and then some of them are going to think they're getting the drug, but they get nothing. It's just a sugar pill. And then you evaluate whether there's a difference in the experimental group, the ones getting the drug, and the control group, the negative control group that don't get the drug. And if you can see a difference, you can pretty much show that you can look at the effectiveness of the drug. Now, you even go beyond that, because if you are a company, scientist who has this drug that you've developed, you're like, oh, please, 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 I want it to work. I'll get a promotion. I'll make more money, right? And they're biased. So what do? They don't want that to happen, because you don't want to put a drug out onto the market and that does nothing. So what they do is they do what they call a blind study. The scientist doesn't know who is getting the drug and who isn't getting the drug. And not only do the scientists not know, the patients don't know. They don't know if I'm getting the drug or if I'm getting what they call the placebo, the sugar pill. And this is what we call a double-blind study. And it helps to remove what we call bias. Bias is where you kind of manipulate the data. It's not truly lying, it's just you want it to be this way, so you tend to evaluate the data in a not harsh manner. You want it to be absolutely a harsh, yes, no, it doesn't matter what you feel or think. So we use blind experiments, double-blind experiments, to help remove bias. All right, so we said, in science, the data builds up over time. Just think about that Hudson Bay Company study. It's literally a study of the population dynamics of various species of animals, fur-bearing animals, over hundreds of years. It's cumulative. And if you look back over hundreds of years, you can see this repeating pattern, and so it's supported, right? And so you come up with a consensus. People look at that and they say, yeah, I agree. And what about you over there? Come on over here, look at this data. What do you think? And you say, yeah, it looks right to me too. So science comes to what we call a consensus, and that's where the majority of people accept whatever the hypothesis is. Okay, an example from the 1300s. Science was very kind of going through a primitive period there way back when. And, they had this idea that rotten meat would somehow spontaneously generate flies. So if you think about it, you see a deer, it just got run over on the road. And you go over to it and you say, oh, that is disgusting. I don't like to look at it. But there's not a fly in sight. Absolutely nowhere. And then you say to your friend, hey, come on, let's go look at that deer. And it's been a week. You go over to that deer and it's just in a cloud of flies. And they literally, this was an idea. They thought that flies spontaneously generated from meat. Well, somebody finally figured out that no, mama fly will lay eggs in the meat, and a few days later, you get maggots that are chewing away on the meat, and then they emerge as flies. And so all of a sudden you realize the meat didn't produce the fly, a mama fly did. And so then you bring all the other scientists over and you say, look, it's not the meat, it's mama flies that produce the flies. They just laid the eggs in the meat. And all of a sudden, you went from everybody thinking that meat made flies, to everyone thinking mama flies lay eggs in meat. And what do we call this? A paradigm shift. A shift in the thinking of science. Okay. So, I'll come back. We're going to talk about statistics just a little bit and then keep on going.